So Tipping Points is a program that funds technologies and businesses that are at the tipping point of creating big industries in space. And there's no technology that I can think of that's more at the tipping point than the combination of things that we'll be demonstrating here. We'll be demonstrating new technologies for Momentus in Momentus's space transportation business, and we'll be putting to bed so many technologies for asteroid mining. So we think we have a high chance, if NASA makes an opportunity for Tipping Points, to win this. But what we're planning on doing is flying Mini-B into space for cheap, for relatively low cost, on a big rocket on an ESPA ring. So these ESPA rings, they attach to the rocket, and you put the ESPA ring. And on top of the ESPA ring, you put the big satellite that was being launched. And then the ESPA ring has multiple stations on it, where small sats can be launched into space. So what we intend to do is use 2 of the stations on the ESPA ring for our mission. One will hold the Mini-B with the Momentus Vigoride bus, and the other will hold the artificial asteroid. So it goes into space. The artificial asteroid is let loose. The Mini-B is let loose. The Mini-B deploys its solar concentrators, deploys the asteroid capture bag. This is the bag that will capture the asteroid in. That artificial asteroid goes tumbling out into low Earth orbit. The Mini-B flies up to it, rendezvous with it, captures it in the bag, cinches the bag closed, turns those concentrators on the sun, and through the optical train, sends that sunlight into the artificial asteroid and does optical mining on it right there in space.
It's time for another episode of the Cold Star Project. We're focusing on small sats in space and my favorite thing, asteroid mining. And we're here with Joel Sercel, who I'm super, just bananas excited to have on the show because, well, he has got so much experience and so much technical know-how of having done this stuff for so long. You're a doctor of space propulsion and plasma physics. That's from Caltech. And you're with 2 companies right now, TransAstra, which is your company, which is all about optical mining technology. We'll be getting into that. Kind of picks up an asteroid in a bag and mines it inside, which is really cool. I watched some videos of you presenting on this. And then you're the Chief Technology Officer at Momentus Space, where you're using water-based propulsion technology. So I'm super excited about that. And you're talking about cost reduction. Basically, you get a launch vehicle to send the vehicle up into low Earth orbit, and then your company or Momentus will kick that out to some custom orbit way out there. So thanks for being here. Let's jump right into it. You have, Joel, some of the deepest experience that I have seen so far. I've been connecting with a ton of people in the space industry. Everybody's super friendly, which I'm very appreciative of. You are a principal engineer and project manager at JPL, and you designed their space project process, which, being a process engineer, I'm like, wow, this is really neat. So I'm curious, what was your biggest surprise or learning experience there? And I imagine it's a people thing, not a mechanical thing, but over to you.
What was my biggest learning experience?
Yeah.
As the chief architect of JPL's end-to-end process? Oh, wow, that's great. Because that's also a little bit of ancient history for me. That was in the late 1990s. Couple of things. One, when it comes to process design, the KISS principle applies. Keep it simple and successful. And 2, it is all about the art of leadership and culture. And how do you change a culture to embrace the values that get you to the business goals that you need? And so, and the hardest thing in the world to do in any organization is to change its values. So that was a tremendous learning experience for me, which then, paid off in many other settings since then. I was the chief systems engineer of a multi-billion-dollar Air Force satellite communications network. Tried to get the Air Force to be more efficient and systematic in its systems engineering processes. And those lessons from JPL really applied a lot. However, let me just go back. That was a wonderful introduction you gave about me. And it stroked my ego like crazy. So for the rest of the day. But I did want to just point out that TransAstra, by the way, do you know what this picture is here?
Is it of your, it's of this, you tell me.
Okay, well, I'll tell you,
I guess it'd be wrong.
I'll say stay tuned for later in this podcast, and I'll tell you what this picture is.
Okay.
But TransAstra is a space resource mining company.
Mm-hmm.
And our optical method of asteroid mining is one of our cornerstone technologies. But we are also very into lunar ice mining, and we have some really exciting inventions in that area, and we'll be making some exciting announcements about our work in that area in the coming days. But this is something we're extremely excited about because, and it involves both Momentus and TransAstra. You can see the TransAstra logo there. That's the mini-B asteroid mining tech demo that NASA is paying TransAstra and Momentus to work together on to build the engineering hardware for, to fly that in space in a few years in low Earth orbit. And what you see, this integrated system is the mini-B tech demo. We'll be flying an artificial asteroid in low Earth orbit on that. That'll be made by our colleagues at the University of Central Florida. And that spacecraft bus at the back there is the Momentus Vigoride bus, okay? And the Momentus Vigoride bus is part of Momentus's in-space shuttle service that it will be using to ferry small sats and microsats all over low Earth orbit using water as propellant. But this will be the first demonstration in space of mining water from a material that simulates extraterrestrial resources. And we are very excited because NASA has selected the combined TransAstra Momentus team, along with our other partners, including Lagarde Corporation down in Orange County, that'll be building these thin film solar concentrators. The Colorado School of Mines, where we're collaborating on optical mining technology. The University of Central Florida, that has the science for how to make that artificial asteroid. A company here in Southern California called Technoplanet, which specializes in the mechanisms that'll put all this stuff together. So we have this great collaboration, and we are just thrilled that NASA is funding us with, we're one of 2 of the first ever NIAC Phase 3 contracts. And they're funding us $2 million, which then we're matching with our investor funds to build that sucker, which is something that, actually that picture is about half scale.
Oh,
It's
okay.
called the mini-B because it's actually a small sat version of an asteroid mining vehicle that demonstrates all the aspects of asteroid mining, from capturing the asteroid to trapping it, to using optical mining to drive the water out, collecting that water in crowd traps, and then using those same solar reflectors in a solar thermal mode to actually propel the spacecraft around in low Earth orbit using solar thermal propulsion. So it's the end-to-end demo of everything that we need to go full-scale asteroid mining. And so we're extremely excited about this. And we have a roadmap that gets this in space in about 3 years. And then very quickly thereafter, we go for the Honeybee vehicle, which is Mini-B's big brother. The Honeybee vehicle is about the size of a big communication satellite, the kind that Space Systems Loral or Boeing would make. And it'll get launched on something like a Falcon 9 and fly out to a 1,000-ton asteroid and bring back 100 tons of ice. So this demonstrator is off to the races time for asteroid mining. We're very excited about it. NASA's very excited about it. We're incredibly honored to be among the first recipients ever of a Phase 3 NIAC award.
Right. And for those who don't know, there's a technological readiness level scale. And so to get to this point, you've had to go through many hoops to get to that level.
Yeah. So we've been working on optical mining at TransAstra since 2015.
Mm-hmm.
So I don't know if you know the story of how TransAstra started, but I got involved in space. I think I've been a space engineer and innovator since I was 15 years old. And I used to stay home from sick to design spacecraft and learn about astrodynamics when I was a kid. And I was deeply motivated by the fact that humanity is about to make its leap into the solar system and spread our seed across the solar system, and that will be the immortality project for our species.
Hmm.
And that's always been my direction. So I did my undergraduate degree in engineering physics, did my PhD at Caltech, and went to work for NASA, had a great time, started the NSTAR ion propulsion system that took the Dawn spacecraft to the asteroid's Vesta series. But, you know, they just recently decommissioned the Dawn spacecraft, and we conceived of that mission in 1992. That was too slow. So at the end of the 90s, I kind of got out of the space business,
Mm-hmm.
and consultant and management consultant, trainer, that sort of thing. But a customer actually asked me to do due diligence on SpaceX and evaluate whether they should buy their rockets. And I went and looked at it, and I thought, wow, space is getting exciting. I mean, I'd been lucky enough to work with Jeff Bezos in the early days of Blue Origin, and I was tracking what he was doing. Which is fantastic. You know, it's all about reusability and low cost. When I saw that Elon was getting into the game and there was really going to be a horse race here, I knew that space was going to get exciting. So I looked around and said, well, what do we need? And the answer was we needed asteroid mining technology. So back in 2015, we started writing NASA proposals, won a bunch of NASA proposals, and some investors came to us and provided some seed funding where we did the initial demonstrations of optical mining. And it's been a heck of a roller coaster ever since.
Right. And you guys physically made, I think in the desert somewhere, a light as bright as the sun, essentially, to simulate this thing?
Well, no, close. What we did was we went out to the White Sands facility that the Department of Defense operates in New Mexico. They have a giant solar concentrator. And we used that giant solar concentrator to concentrate actual sunlight onto a sample of asteroid simulant, and demonstrated that we could mine it using sunlight, demonstrated that we could excavate the sample and drive those volatiles out that are the ingredients of rocket propellant. And the most important rocket propellant is water. But then you can take those volatiles, oxygen, hydrogen, all that kind of other stuff, and you could do liquid oxygen, liquid hydrogen propellant, which is what Jeff Bezos is doing, which I think is absolutely the right strategy. But you also get methane, so you could do methane LOX, which is what SpaceX is doing. And so we were able to demonstrate optical mining, which it culminated in that big White Sands test, but we also did subscale tests at Colorado School of Mines. Now, more recently, and we're just writing the final report for this activity over the weekend, here we are in early November. NASA actually funded us with a phase 2 NIAC to build what we call the optical mining test bed, which is a large facility indoors with a simulated light source that makes it easier to do experiments in optical mining rather than having to use that giant solar concentrator.
So you should get a faster turnaround because you don't have to wait to use that particular product.
That's right.
Okay, very cool. I'm curious, so you've got this design, the Mini B behind you. What trade-offs were you conscious of making when you came up with this design?
The Mini B?
Yeah, it's always this versus that.
Right. So really, here's what drove the design of the Mini B, and that is for asteroid mining to make sense economically, you have to go big. The smallest asteroid that it makes sense to go after is in the range of hundreds to 1,000 tons or so. All right. And so for that, you need a big vehicle, which is our Honeybee. By the way, all of our vehicles and systems at TransAstra related to asteroid mining are part of what we call the APHIS architecture, APIS, Asteroid Provided In Situ Supplies. APHIS is the genus name for honeybees. So it's really based on how honeybees go out and gather nectar and bring it back and that sort of thing. So the issue is the honeybee is a big system with lots of complex technologies in it. And it's difficult to get a sponsor, whether it be NASA or the private sector, and we think it'll be a combination of both, to step up to the big dollars, hundreds of millions of dollars, maybe $150 million, to build the honeybee and launch it in space on a medium class launch vehicle, You could put 2 honeybees on a New Glenn or 1 honeybee on a Falcon 9. That's a lot of money if you haven't proven it all in space.
Mm-hmm.
So the design driver for Mini-Bee is what's the smallest vehicle that we can do, small sat class vehicle that demonstrates all the aspects of optical mining of asteroids in space. And then we realized you can't find asteroids that size,
Right.
size of a beach ball with telescopes. So we decided to make our own and launch it into space with Mini-Bee. So are you familiar with what this is here?
No, you'll have to tell me.
That is an ESPA ring.
Ah.
So an ESPA ring is this way that small vehicles can launch into space on a big rocket for cheap.
Mm-hmm.
So, the small rockets are wonderful for lots of things. They get you into space when you want to go into space, at the inclination you want to go, and all that kind of stuff. But on a dollar per kilogram basis, the big rockets are a lot less expensive. But what we're planning on doing is flying Mini-Bee into space for cheap, for relatively low cost, on a big rocket on an ESPA ring. So these ESPA rings, they attach to the rocket, and you put the ESPA ring. And on top of the ESPA ring, you put the big satellite that was being launched. And then the ESPA ring has multiple stations on it where small sats can be launched into space. So what we intend to do is use 2 of the stations on the ESPA ring for our mission. One will hold the Mini-Bee with the Momentus Vigoride bus, and the other will hold the artificial asteroid. So it goes into space. The artificial asteroid is let loose. The Mini-Bee is let loose. The Mini-Bee deploys its solar concentrators, deploys the asteroid capture bag. This is the bag that will capture the asteroid in. That artificial asteroid goes tumbling out into low Earth orbit. The Mini-Bee flies up to it, rendezvous with it, captures it in the bag, cinches the bag closed, turns those concentrators on the sun, and through the optical train, sends that sunlight into the artificial asteroid and does optical mining on it right there in space.
Right, and you're able to do this for $4 million.
So for a few $1 million, we're building the engineering model hardware for this, and the exact costs for this are proprietary. What we do say is that NASA is providing us $2 million, which then we're matching in different ways, to actually build the engineering model hardware. And then the follow-on to that will be another mission in a program such as NASA's Tipping Points, assuming that we were lucky enough to win that. But we're pretty optimistic about being able to win NASA proposals. We've had a very good track record. And so Tipping Points is a program that funds technologies and businesses that are at the tipping point of creating big industries in space. And there's no technology that I can think of that's more at the tipping point than the combination of things that we'll be demonstrating here. We'll be demonstrating new technologies for Momentus, in Momentus's space transportation business, and we'll be putting to bed so many technologies for asteroid mining. So we think we have a high chance, if NASA makes an opportunity for tipping points, to win this. And part of the reason we're optimistic is you mentioned technology readiness levels. In the space business, there's a thing called the Valley of Death, where you do the early stage technology, but then no one will pick it up and fly it. And there's this in-between stage that's missing. The NIAC Phase 3 program was set up by NASA for that in-between stage. And so NASA has programs like the Tipping Point and others that are designed and that haven't been accepting these really breakthrough concepts from NIAC. NIAC formed the Phase 3 so that we could do this engineering model hardware to get it ready to fly on those flight demonstration programs like the Tipping Point. So we're optimistic that if not Tipping Point, then somewhere else in NASA, a combination of NASA funds and private sector investors will come in and we'll make this happen. We have reason to be very optimistic.
Yeah, well, I agree. Having gone through, your history, the marketing literature, the videos, and all that, why not, right? Who's got a better track record than you and your teams of putting this stuff together and actually making it work? So,
well, thank you.
And I wouldn't say that just because you're here. Sometimes I'll talk to dreamers and I'll know that, they're working hard and whatnot, but the gap between where they are and where you are seems to be quite large. Yeah, I
Well,
think
my
we're
ego
right up at the front of
exploded today. So thank you.
it. Well, that's exciting for me. Hey, this is Jason Canigan, the host of the Cold Star Project and the founder of Cold Star Technologies. I've decided to do something new. I've started doing daily update videos on who I met and what I learned the previous day in the space field. And it's a great sort of follow me thing. You can learn what I learn. I'm meeting a heck of a lot of people and learning a lot of things really fast. And the space field is really disparate. There are tons of nooks and crannies to go into and explore, from legal, operational, regulatory, compliance, and gosh, the end customer. Who'd have thought about that, right? So you can sign up for this. If you go to coldstartech.com/MSB, that's short for Make Space Boring, the mission we're on, then you can sign up, and in your email you will get a daily notification that the new video has been posted. I'm also thinking about doing some branded mini courses and summarizing papers as I'm able to. So those will be some goodies that are in there as well. So if you're interested in that, go to coldstartech.com/MSB and join us on the mission to make space boring. Now back to the interview. I want to hop back for a second, and we'll return to TransAstra in a moment. You were the chief systems engineer for something called the Transformational Satellite Communications System at the Space and Missile Systems Center, which sounds incredibly scary. And I'm curious, this is directly from your LinkedIn profile. You mentioned taking the process maturity from level 0 to level 3 in 6 months. And so the operations management guy in me is really curious about what you mean by process maturity and what that was like. And I don't need any secret information, right? But I'm interested.
No. So in the world of process engineering, there are maturity levels. And, there's like CMMI has a certification for software maturity. Well, they also have a certification for systems engineering maturity. And so, and it's a 5-level maturity index. Level 0 is you don't have processes, you just do work, right? Level 1 is you have basically defined processes, but you don't measure them, And then there are, and it's been a while for me since I've worked in that world. But CMMI level 3 is basically you define the processes, you constantly execute according to the processes, you measure compliance relative to the process, and you're constantly looking to improve the process. And when I started at LA Air Force Base in systems engineering there, the process maturity was basically level 0 or level 1. And because I'd come off that JPL experience that you talked about, I had some concepts of how to increase the maturity of an organization. And the issue is that it was a $22 billion satellite program that we were initiating, and they had many requirements documents that had to be written. And there was a capstone requirement document that had like 1,500 requirements in it, and probably 300 people that had to coordinate on every one of those requirements. So we built what I called the requirements factory to make that happen. And the way the requirements factory worked was I had a small army of systems engineers who were working on different sections of the document, and each requirement was identified and coordinated, and then there were a series of coordination meetings all laid out every week, like a factory process flow actually, that would lead to a proposed requirement coming to a change control board that I chaired. And as I recall, the change control board was always on Thursday afternoon. And if there wasn't concurrence from the people, we would discuss the issues. I'd send it back into coordination for another week. And if they didn't coordinate the following week, then I would have them bring a decision, and I would board the requirement in. And and through this process, we dramatically increased the maturity and the speed at which that these requirements could be written. It's too bad that Department of Defense, and to a certain extent, some other agencies, not all of NASA, but some of NASA, not all of the DoD, but much of the DoD, uses this requirements-based systems engineering process for acquisition. Acquisition means buying systems that don't exist and having contractors build them. It's a very inefficient and cumbersome process, but if you're stuck with it, then the way to do it is to be as systematic as possible. We don't do anything like that at TransAstra or Momentus.
Hmm.
It would be poison. So it's much more. We try to get process maturity, but for different types of processes based on different value systems.
Mm-hmm.
At Momentus and TransAstra, it's all about innovation, invention, physics, collaboration, daring, bold, efficient, those kinds of things. So it's a very different game. But then when it comes down to building flight hardware, that's where you have to dot your I's and cross your T's, understand the failure mechanisms, and be very, very serious about those requirements that you have to meet, how you're going to verify them, how you're going to validate them. And then rather than going through and really chomping through all the requirements in gory detail, what experience shows us is the trick to real systems engineering is close-knit teams that are passionate about the work, that test and build and test and build, and then system level test is where it's at. And you system level test the system to make sure it works. And so, while the part of DoD that I was in those days is very much a waterfall-based, top-down systems engineering approach, new space and microsats and the kinds of industries that are being built, they're really centered on agile methods, which really, aerospace agile is different than software agile, but it borrows a lot from software. And if we had 3 or 4 hours, I could give you a lecture on that.
Well, I would like that sometime. I don't know if everyone else would be interested in it, but for me, I'm very curious how you're getting to that sort of same end result of understanding and having clarity on what you're doing and how to make sure things don't break and to get to the mission success rate that you want. Without getting bogged down in a slow, iterative feedback loop, right? That takes forever.
So what you want, the answer is a fast, iterative feedback loop. And it's more about building and testing and trying stuff than analyzing things. I used to believe that the right approach was to measure twice and cut once. And what I've learned is if you're trying to innovate, you cut 3 times, test and measure. Cut 3 times, test 3 times. When you've got it working, then you do your measurement. And innovation and discovery is about being willing to fail fast and learning from failure. I have a motto that I tell the R&D team at Momentus all the time, which is all knobs to the right. If you haven't broken something in the lab this week, you're not working fast and hard enough. And so the team will sometimes, I'll say, how'd it go in the lab? And they say, well, we burned out this component. We say, what happened? Well, we were testing it and, we kept turning up the power. And at this power level, we found it broke. And I say, that's how you do it. Test to failure and test to failure fast. And so one of the things that we do at Momentus is this was something that most of the folks from Momentus just fully embraced Agile from day one. Momentus embraces diversity. We have people from all different technical backgrounds. And I told the team, hey, we're building an in-house machine shop so that we can turn parts in hours instead of days. They said, you're crazy. We just bend it out. It takes a few weeks to get the part back. No problem. But in our R&D efforts, we need parts. Our R&D team, makes dozens of parts in a month. We can't wait weeks for parts. That would be ridiculous. And then even for flight hardware, if you're we're machining the Vigoride bus, that bus right there is on our big multi-axis machine tool right now, being hogged out of a big chunk of aluminum. It's really cool to watch it,
Right.
You can kind of see in that picture the isogrid structure. It's nice to see how that gets machined out. And sure enough, when we were machining it, we broke it. Well, that's why you machine it in-house, because you get insight into the manufacturing process and you see what breaks and what doesn't break. And there's nothing like getting your hands dirty if you really want to succeed.
Right. Yeah, I love that institutional knowledge, right? You can't fake it. You can't really buy it. And once you got it, they can't take it away. So,
that's right. That's right.
That.
And then that institutional knowledge is embedded in the minds of your people. And so reward your people, let them know how important they are to you. And everyone talks about that. And you can walk into a company and see the difference. I think in the last 8 weeks, I've hired 40 engineers at Momentus personally. And it is one of the most exciting things for me is just walk into that engineering floor and just feel the intensity of people behind their workstations and up at whiteboards and then walk into the lab and you walk straight from the engineering floor into the lab and you know, it's back and forth between those and you see the guys hunched over their lab benches cranking and burning microwave components and all kinds of other things. It's just thrilling. It's absolutely exciting.
Yeah, and I love the idea of just like go ahead and break it and don't worry about, okay, this is going to cost us some money. You know, as long as you can absorb it.
Often as CTO of Momentus, engineers will come to me and they say, hey, we need to buy some of these components, you know. And I say, well, how many do you think you need? Well, we need, you know, we need the EM model, and then we need you know, the brass board, and then we need the test unit and the flight unit. So, you know, 4. And I'm like, you need to buy at least 6.
Yeah.
Probably 8. And I can't tell you how many times. Okay, it's just something like, I'll tell you, you know, a story from the lab at Momentus. Do you know what 80-20 bar is?
I know what the 80-20 rule is.
Well, the 80-20 rule is used for this stuff called 80-20. It's these machined aluminum bars that are called 80-20 bars.
Okay.
And for 20% of the cost, you can do 80% of all the structures that you need in the lab. So, and I said, you guys, I want to see stuff made out of 80-20 here, okay? For laboratory work, we can quickly assemble structures and that sort of thing and see how they go. And some of the engineers were ordering 80-20, and they brought to me the order, and I looked at it and I said, I need you to order 4 times as much. And they looked at me like, you're crazy. And they ordered 4 times as much, and then 2 weeks later they came back and said, we're out. And I said, okay, this time I want you to order 6 months supply. Okay. That was 3 months ago. They're just about out again. And so the point is you've got to have inventory. And people say, well, we can get it overnight. But if you're iterating rapidly in the lab, overnight is too slow. So the spirit of innovation and discovery, you know, it's rapid innovation is what gets you to success in the modern world of, you know, 2019, 2020 now we're going into. It's rapid, you know, it's collaborative computer-based engineering, software tools that control your requirements, linked, you know, we have interns that we've hired at Momentus that went back to school, and they're still doing CAD designs for us, and then it's all integrated through our system. So.
Very cool. Let's say you get, you will get a bunch of these honeybee ships up there, grabbing asteroids and whatnot. What happens if one of them breaks? What kind of repair process have you got? Is it some kind of self-healing thing, or does another ship have to fly up to it to fix it?
Well, eventually the honeybees will be, you know, repairable, but initially they will be expendable.
Okay.
And so this is all about statistics. So you never build an aerospace company with a success-oriented mindset. Okay, you need to plan for failure in the process. You know, there's, you know, many countries have tried to land on Mars. So far, only JPL has done it. And only about 75% of JPL's Mars landers have worked. Maybe it's a little higher than that now. You know, in the first dozen launches of any new rocket, there's at least a 50-50 chance of a catastrophic failure. Doesn't matter who's building it. And so, what you have to do in the asteroid mining business, the prospecting is going to be done with telescopes based on statistical models. So there'll be a certain probability that when you get to an asteroid, it's actually water rich. And so you have to calculate all these probabilities and the reliability of the system and build that into your economic model. And just like if you're building a mine, you have to have an idea of what the known failure rate of the digging equipment is. It's the same process.
Okay.
Now later on, I remember many years ago, I was in a conversation with a certain unnamed space billionaire, uh, and we were talking about the role of humans in space. And he said humans have no practical value in space
Hmm.
when it comes to space industry. They're, uh, and and I think we'll get to the point where teleoperation for repair will be the way to go. And then modern manufacturing technology, additive manufacturing, and other related approaches will allow us to fabricate parts in space and replaceable parts in space. But that'll be a while until we get there.
Right.
Humans are going to be incredibly important in space in the coming years and decades because humans want to go to space, and we're willing to expend a lot of resources to go into space. And so so humans will go into space for fun, and that'll be a huge industry. Suborbital flights, then orbital hotels, then lunar hotels. Lunar hotels will be an important cornerstone user of water in space that will drive both lunar polar ice mining and asteroid mining. And that's going to be huge. And once the networks, the transportation and supply networks are in place to support large NASA and other government scientific outposts on the lunar poles, that'll grow into hotels on the lunar poles. And then that transportation infrastructure will make it so cost effective that people go to space to live on their own nickel. And then those space workers, their proximity to the factories that will be building things in space will enhance productivity. And so humans will be a critical linchpin in driving space industrialization.
Well, I happen to agree with that. And I'll start from my much dumber perspective in that communication is a problem with these large distances, right? The further you go out, that it's not much farther than the moon, you start getting a real gap in response times and whatnot. So
absolutely, even teleoperation over lunar distance with the, I can't remember offhand what the light delay is, but it's on the order of seconds. That really messes up teleoperation.
Right.
And AI is an incredibly powerful technology, and also little overhyped. So making practical robots that can do the kinds of things that people can do in the short term is going to be really challenging. So you design your systems to be highly reliable based on test and practical experience. And then for maintenance that has to be done, servicing, you design them to be as modular as possible. So the dumbest possible robot can do the work in a combination of autonomous mode and teleoperation.
Right. And that is something that I'm really excited about. I love modular design and self-repairing robots and not having to go and re-engineer something from scratch just to
there you go.
Just to get it done. So what should people be looking for next from you and TransAstra and Momentus? This is going to happen.
So Momentus has our El Camino Real spacecraft in orbit now. It was launched on July 4th, California time. And it's been functioning fantastically in space for months. We've done dozens of burns with our microwave plasma water propulsion system. And we'll be extending that. We're validating certain aspects of our avionics, software, attitude control sensors, and the microwave plasma propulsion system in space. And we're going to be upgrading the autonomy on that and learning low-cost operations through that system. And so we'll have blogs and press releases and that sort of thing. Go to www.momentus.space and read the blogs on that to stay tuned. Momentus will be launching test missions in 2020. We won't be announcing those in advance, but don't be surprised if you find out that there's some pretty exciting spacecraft that look like the bus in the back of that doing some really cool things in orbit. And Momentus is taking orders for in-space transportation services now. And, we completed a roughly $35 million Series A venture financing a few months ago. and we'll be moving into later stage financing. There'll be some big announcements on that coming up. Really revolutionizing in-space transportation by deploying constellations, large and small, of microsats and small sats in the 2021, 2023 timeframe. And then moving from low Earth orbit to geostationary orbit and throughout cislunar space with a series of different types of shuttle services in the coming years. So Momentus is an incredibly powerful financial play, revolutionizing in-space transportation using water as propellant. Momentus and TransAstra are partnered, and the partnership is centered on water. TransAstra will be the preeminent water supplier from extraterrestrial resources from both the asteroids and the moon. NASA has funded TransAstra to define a lunar polar mining outpost. And if you want, I can send you the link to a video where I outline the technologies and what we're doing there. It's very exciting. We have discovered that there is absolutely no need for nuclear power for multi-megawatt mining operations in dark lunar craters. And we've got some very powerful inventions, which I can talk to you about now if you want, or I can send you the link.
Sure. Yeah. Either would be good, or you could come back on and we could have another time to talk about that.
Why don't we do that? Why don't we do a lunar polar mining podcast?
That would be great.
I'll show you artist concepts for how all this stuff works. And I tell you what, I won't say how it works today. Instead, I'll come back, and that's a teaser for your audience for the next get together. So TransAstra is doing our phase 3. We'll be having some nice announcements about our NIAC phase 3 and follow-up activities. We're working in telescope technology to find the asteroids and lunar mining. So it's all very exciting. And things are moving so fast I can't even believe it.
Yes, yes it is. Yeah, and I'm happy to be teeny tiny part of it and seeing what you're doing. So my guest today.
I'd love to get the word out. Thank you so much for inviting me today.
Thank you. My guest today has been Dr. Joel Sercel, a guy who is pretty amazing and has been around in this field a long time and is continuing to do really powerful stuff in the industry.